What is mean by solubility is? Any idea? Yes. How soluble it is? Yes. What is it?
Like dissolves in water.
Dissolves in water? Okay. So solubility means if I have 100 ml of water, how much sugar I can dissolve in 100 ml of water at room temperature. That is called solubility. So how will you define it? It is the amount of solute. It is the amount of solute. And you have a detailed definition on next page, okay? It is the amount of solute dissolved. You can write a simple definition here and detailed definition on next page. Then what is mean by a solution is? Solution. What is mean by a solution?
Solution is the combination of solute and solute after.
Combination of two or more things. Give me an example. Sugar water. More example. More example. Like different type of example. Not liquids. Okay. You are saying all liquid example. Salad. The salad is not a solution.
Snow cones.
Salad is not a solution. Solution means it must be a homogeneous mixture. What is mean by homogeneous is? Looks same throughout. Say for example, you are dissolving sodium chloride in water, okay? Completely dissolved. Can you see sodium chloride there?
Hopefully.
Can you see water there?
Probably.
No, you can't see both. You are seeing only what? Salt solution. Okay? That means that is called homogeneous. Everything looks same like a single substance. Okay, give me examples of solid solutions. Say that again? Cake. If there is a plain cake, I would say, hey, I will take it. Any other example?
Frozen soup.
Frozen soup.
Yeah.
Okay, give me example from this room.
The door.
Door is made of wood. It is a compound. Okay, look at this. What is this one is?
It's metal.
It is a metal. It is not a single metal. It is called stainless steel. Stainless steel is made of, what are the metals in it?
Iron.
Iron is there, chromium is there, nickel is there. It is a mixing of iron, chromium, nickel. Or if you have a gold jewelry, okay? Gold jewelry has gold and copper in it. So, those are called alloys, okay? All alloys contains metal mixed together. Okay, that is an example for a solution. Give me some gaseous solution from this room.
Somewhat.
Gas, everything gas, gaseous.
The oxygen.
Oxygen is a single system.
Carbon dioxide.
That is also a single thing because it's carbon dioxide.
It has two different.
But it's chemically connected, so that is single now. It's what? Air, very good. Air has nitrogen, oxygen, and there are so many other pollutant gas, all those things, okay? Those are called solution. So, go ahead and write homogeneous mixture. Homogeneous mixture means it is uniform everywhere. One substance dissolved in another. Okay, I'm going to give the basic definition. Solute, how will you define solute is? Yes, substance that get dissolved. Or present in less amount. Okay, that is the standard definition. What is solvent is? Substance that does the dissolving, or we can say medium that does the dissolving. Or the component dissolving component which is present in excess, large amount, more. Why water is considered as a universal solvent?
Polarity.
Yes. So what type of bond is in water? No, like this bond. What type of bond? Covalent. So water can dissolve all covalent bond. Any covalent bond, like sugar is soluble in water, okay? So many covalent compounds. Carbon dioxide is soluble in water. Also, water is polar. So, because of the charge, it can also dissolve other polar substance or other ionic substance. So, water can basically dissolve so many. That's why we are all living, okay? Okay, so here salt water is given. Who is a solute in this? In salt water, what is a solute?
Salt.
Salt is a solute. And in what is a solvent is? Okay, go ahead and write that. It's a tough one. Okay.
Sugar.
Lemonade, what is the solute is? Yeah, sugar and lemon juice, whatever the flavor is.
Kool-Aid flavor.
Yes. And what is a solvent is? Water. And air. Who is the solute in air?
A lot of gas.
Who is a solvent in air?
Air. O2. Oxygen.
Hmm?
O2.
No?
Hydrogen.
Nitrogen. Nitrogen is present in more than 70%. Who is present in less than amount? Oxygen and a lot of other gases. Depends upon where you are living. There will be lot of pollutants too.
Like in China.
Nitrogen. Okay, how many type of solutions possible based on the physical state? So maybe solid, liquid and gas. How many type of solutions possible? Total. Infinite. So we can have solute, solid, liquid, gas. We can have solvent, solid, liquid and gas. 9 type of solution possible. Because these are solid, liquid, solid, gas, liquid. Yeah. Okay, here. The principle for dissolving same type of bonds can dissolve same type of bonds. So, polar can dissolve polar, non-polar can dissolve non-polar. So, carbon tetrachloride, methane, CH4, okay, those are non-polar. They are called hydrocarbons because it contains carbon and hydrogen. And CO2 is polar. Okay, those are the difference between polar and non-polar. Go to the next page. Okay, so when you dissolve something, we are saying dissolving. Till this point, you know only definition, dissolving something in water. But if it is covalent or if it is ionic, there are different terminology we are going to use. So, say for example, if I am adding salt, which is sodium chloride, into water, it will form what and what? It will dissociate or ionize into Na plus and the Cl minus ion. So, if you can see the molecule with your normal eye, this is what you will see. There is a sodium ion here. There is a chloride ion here, and I know that there are a lot of water molecule. Water has positive hydrogen and negative oxygen. Who will attract towards sodium? Oxygen. So you have to draw like this. This is water molecule. It will attract. All water will connect towards so you will be surrounded by like this. Reason, because oxygen has negative charge, sodium has positive charge. And who will be attracted towards chloride ion? Hydrogen. And you will have questions over that on your test. Okay, you have to just explain, understand and explain who is going to connecting to who? Okay, hydrogen will attract here. So we can explain. And this process is called dissociation or ionization, or we can say dissolving. Okay, ionic compounds will form ions in water. The positive hydrogen, just underline this. And you will see the exact same image I drawn here. It is on the slide 2 on your test. Okay, covalent molecule. Give me an example for a covalent molecule. Which is soluble in water. What is this is?
Baking soda.
No, soda, club soda, Pepsi, all fizzy drinks. What is the solute in that?
Carbon dioxide.
Carbon dioxide is there, sugar there. Both are covalent, okay? I'm going to show you carbon dioxide in water. This is carbon dioxide. Will carbon dioxide split into carbon and oxygen there? Yes or no? No, why? What type of bonding there? Will they split into ions? No. So, but we know that carbon dioxide is polar, so all water molecule will be, you can say, just write H2O, 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 H2O. They will not split into ions, but water molecule will attract them because they are polar. Okay, and that is called solvation or hydration. Solvation. So, covalent molecule will not form ions in solution, but ionic molecule will form what? Ions. The negative charge will attract to positive hydrogen, and positive charge will be attracted to negative oxygen. And this is very important. You will have questions on your test. Okay, this is the same thing. Okay, covalent molecules are hydrated, they will not separate, and there are 2 examples you have to draw. This is ionic and this is ionic and this one is covalent. Okay, figure it out. Next page. Okay. Now I am going to teach a solubility curve. That is the second part. Okay. Yeah, we're already talking about solubility. Solubility is the amount of what? We already wrote a definition on the last page. Amount of solute that can be soluble in a solvent at what? At a certain temperature and pressure.
So, like a graph.
Okay, yes. I'm going to teach you something called the solubility curve, and how are you going to decide about the type of solution. There are 3 types of solution you will see. Okay, say for example, if I'm going to drink 1 cup of milk, okay, I don't like sugar, so I may add maybe half a spoon of sugar in it. Half a spoon of sugar and dissolve that. Is that enough sugar for 1 cup of milk? No. So I would say this milk again can dissolve more sugar in it. That type of solutions are called unsaturated solution. Unsaturated means more solute can be dissolved. Okay, now I'll take another cup and I'm going to give that to Hunter, and Hunter said I need 5 spoons of sugar. So I'm adding 5 spoons of sugar and stirring it. I know 1 cup of milk is not able to dissolve 5 spoons of sugar. Okay, so I can see there will be still leftover sugar on the bottom. It already dissolved maximum amount. That is called, I am saturated. We can say that is called what? Saturated solution. Okay, now, but I feel sad because Hunter told me he need 5 spoons of sugar. So I will decide something. I need to dissolve. I am a chemist. So I put this in the microwave and heat the milk for 5 minutes and see all the sugars are dissolving. Because for solid, if you increase the temperature, there will be more solute you can dissolve. So now that is dissolved 5 spoons of sugar, I'll take that out of the microwave, keep it on the countertop, let it cool for room temperature without disturbing it. Then you will get a solution that is highly unstable. That solution is called what? Supersaturated solution. So these 3 will be on your test as a definition question. Okay, there are 18 questions in your test. So all of them basically just your note packet, okay? And there are some calculation questions from the next page.
Can you explain without the milk part of it?
Okay, if you have 100 ml of water, it can dissolve maybe 10 gram of sodium chloride. So if you dissolve all the 10 gram there, that is the right amount it needed. That is called a saturated solution. But it can dissolve 10 gram by added only 5 gram, less than it needed. That means it still can dissolve more. That type of solutions are called unsaturated solution. Supersaturated means I added 20 gram there and heated the water boiled the water for 10 minutes and made all the solute dissolve and cool down to room temperature. It is an unstable solution because it dissolved so many solute, and that is called supersaturated. And you will understand from the graph in a minute more. Okay, so the factors affecting solubility. If solute is a solid, I said if we increase the temperature, what will happen? Solubility will increase. Or you can stir them, or you can powder. If you have a block of sugar or powder sugar, we know that powder sugar will be easily soluble. Okay? But if it is a gas, if we increase the temperature, what will happen? If you have soda, if you microwave the soda, what will happen? It go flat, okay? So you always keep soda where? In the refrigerator. You need cold temperature. So decrease in temperature increases what? Solubility of gases. Soda, if you have a soda maker at home, you might have seen that we are applying very high pressure to fill the soda. So gases, if you increase the pressure, solubility will increase. Okay, good? Okay, get ready. I am going to teach you the graph. Those will be the majority of questions for your test.
I'm scared.
You're scared? It is very easy. Look here. This is temperature on the x-axis, and this is grams of solute in 100 ml. If you can't read it, just write one more time. Grams of solute, 100 ml. Okay, everyone look up for a minute. I know you are sleepy last period, but look. It says 12 gram dissolved in 100 ml of water at what temperature? 20. So I'm going to go to 20 degrees Celsius, and this is the point on the line. That is a saturation line. How much needed? Like a 12 gram, okay? So I would say this is right on the line. That is the correct amount needed. That solution is called what? Saturated. So you can say on the line. If the value is on the line, that solution will be saturated. Let's do the next one together, okay? 25 degrees Celsius. Find 25 degrees Celsius. Go up and find the value. How much you needed? 15 gram needed. But we dissolved only how much?
5.
Is it below the line 5? Yes. So that is called what solution? Unsaturated solution. So if it is below the saturation line, you all understand? Okay, next one at 30 degrees Celsius. 30 degrees Celsius, go find how much we needed. Like between 15 and 20, maybe say 18 gram. We dissolved how much? 20. So that will be what solution? Super saturated. Okay. So it is above the line. You understand that? Okay, now we can practice. That's it. We are done with the learning for the next AOL 2. Yay! And this will be on Friday, next Friday.
Not start this part?
No, this is practice here too. This is
Why are they exponential?
Like a spider web.
spider web. Okay, because there are so many solute listed here. Okay, let's do the first question. How much KClO3? KClO3 is this line.
Yeah.
Reading graph is important. Okay, KClO3. Okay, look at the temperature, 65 degrees Celsius. I will go up to 65. Find the point. What is it? 30 gram. That's it. Is that easy? Yeah. If it is easy, your test will be easy. This is the difficult one. What?
Why does it look like this though?
Because it has more lines. That's it. Always you will get the same graph. Okay, you can memorize if you want. You will get only one graph for your test. Okay, next one. Which is least soluble at 50 degrees Celsius? I'm going at 50, and which is the first one I'm eating? It is not cesium. That is called cerium. It's a trans F block metal. Cerium, it is number 58. Cerium sulfate. Okay, let's do the next one. Sodium nitrate. I'm going to find the line for sodium nitrate. This is sodium nitrate. If you don't know ionic compounds, again there is a problem. Remember? Always remember the polyatomic ion. Okay? At 60 degrees Celsius. So I'm going to up in 60 degrees Celsius. Find the point it is meeting the curve of sodium nitrate. 125 is dissolved already. We need how much? 125. So it is right on the line. That's what type of solution is that? Saturated. Right on the line, which will be saturated. How are you feeling it? Is good?
Yes.
Yes. Okay, next one. At least how many grams potassium chloride must be dissolved in 30 degrees Celsius to prepare a supersaturated solution? Potassium chloride is, what is the formula? K? K what? Cl. Not ClO3. Cl. Okay. So now look at 30 degrees Celsius. 30 degrees Celsius it is here. We need, for a saturated solution, we need, I think, a 35 gram. So supersaturated means something above 35. So 35 you needed, so above 35. I would say 36 gram. Just go by one. If it is just 35.1, that is also right. Above 35 gram. Okay, now read the question number 5. Why some of the lines on the graph increases, most of them are increasing, some of them are going down. Did you see one with going down?
Some of them are gas.
Why?
Some of them.
We already learned if it is a gas, solubility decreases with increase in temperature. So go down right. NH3 is going down. NH3 is going down because for gases, you are not writing it? You can write. Solubility decreases. Solubility decreases with increase in temperature. Ammonia, we can realize now from the graph, ammonia is a what? Gas. This ammonia, not ammonium. You know ammonium, okay? So this is, for gases, solubility decreases with increase in temperature. Okay, so rest of the question is yours. Once you done, see, we are done with the packet. So this will be, all this will be AOL number 8, which is on Friday. And it is easy. You need to spend only 10 minutes to study this. Believe in me, trust me.